Welcome back, Algebra 1, to day 2 of Quadratic Functions. So if you look inside the Google Class post, you'll see everything that you need for today. So the first thing we're going to start off with is a short 8-question quiz on quizzes. I want you to finish that quiz, and then when you're ready, press play. So pause the video now. So let's see how you guys did. I'm just going to go through each question one at a time. So the point -2, 4 is called if you remember, that's the highest point on this parabola in this case. That's your vertex. It could also be your lowest point, right? For the second one here, the axis of symmetry it's a line x equals 3, not y equals 3, right? Y equals 3 would be the line, the horizontal line, where all the y coordinates is 3. The point 3, 2 is not the axis of symmetry, right? The axis of symmetry is a line that cuts the parabola right in half. In this case, it's a vertical line, so it has to be x equals, in this case, 3. A quadratic function may be written as a product of two linear functions, right? If you remember from day 1, what we did was we took these two lines and we multiplied them together. Our graph ended up being the shape of a parabola, right? Number 4, choose a statement that describes this parabola. So the zeros of the parabola are -1 and 3. That is correct. If you look at the graph, it hits the x-axis at -1 and 3, and those are also called the zeros of the function because when you plug in -1 and 3 in for x, your output will be 0. That's the same thing as saying the x-intercepts are -1 and 3, 0, so the second statement on the right will be correct. It has one negative y-intercept, that's true. And if you notice, the parabola has an axis of symmetry at x equals 1, not y equals 1. For question 5, choose the statements that describe this parabola. So it's kind of hard to see here, but I believe it says that the x-intercept is 2, and the y-intercept should be 4, right? And then it's also going to be concave up. And so that's your answer there. For number 6, choose the statements that describe this parabola. The parabola has a maximum value, right? The vertex is the highest point in this case, so you do have a maximum value. The parabola has no x-intercepts, that's correct, right? It never crosses the x-axis. The parabola is concave down. If you remember, a frown is concave down. Think of a smile as concave up. A parabola that is concave up will have a maximum value. That is never true. Right? A concave up parabola will always have a minimum value, right? The vertex will be at the very bottom of the parabola. The vertex of a parabola and the line of symmetry intersect. Always, that's always true. Right? They always hit each other. The vertex is right in the middle of the x-intercepts, as is the axis of symmetry, okay? So hopefully you guys were able to do well on that quiz. If you didn't, go back and review your mistakes. And then when you're ready, we'll move on to our next activity, which will be a Desmos activity. So click on the link for your Desmos activity and put your name in, and you should end up with something like this. I want you to work through this entire activity on your own, do the best that you can. At any time, if you're stuck, feel free to play the video because I will be working through them all. And at the end, when you're done, you can check how you did. So at this point, pause the video. So I'm going to work through this. So pretty much if you just mess around with the a value, a couple things you should notice is that when the a value is negative, my graph is always concave down. And when my a value is positive, my graph is concave up. If you look at the p-values here, oops. If you look at the p-values here, look at the p-values and how that corresponds to the line itself and where it crosses the x-axis, right? If you notice that as I move my p-value, my red line is moving. When p is at -2, let's say, do you notice how I have an x-intercept at -2? And when p is 4, my x-intercept is at 4. So my equation for my parabola will be x minus 4, if you notice that. For q values, if q is 1, you notice my x-intercept is at 1. You notice that at q is -4, I have an x-intercept at -4. And pay attention to this factor form on top, right? How h of x is a times x minus p and x minus q. Whatever p is, that is your x-intercept, and whatever q is, that's your x-intercept as well. But notice that it follows a minus sign, okay? So those are some of the things I want you to notice. Now for this, what we're going to be doing is we're going to be creating the function in factor form. So in this case, I have a x-intercept at -4, which means I notice that one of my factors should be x minus -4. Right? It's always x minus whatever your x-intercept is. I have another x-intercept at 2. So I know I'm going to have x minus 2. And if you notice, that does match. It goes through those 2 points. Let's look at the next one. Here we have g of x is a parabola that goes through the given points. Find one possible equation for g of x. So once again, we're going to be looking at the x-intercepts because I know that's where I'm going to put the p's and the q's. So in this case, I have an x-intercept at 3. So I know one of my factors will be x minus 3. I have an x-intercept at 8. So I know another factor should be x minus 8. 3 and 8 are essentially my zeros, right? Keep that in mind. And then you notice it does go through those 2 points. Now for this one, Mrs. Harrington thinks the equation of this parabola should be f of x equals x plus 1 times x minus 4, while Mr. Kim thinks the equation of this parabola should be f of x equals x minus 1 times x plus 4. Who is correct? So if I have one of my x-intercepts at -1, then one of my factors should be x minus -1, which is x plus 1. So it looks like Mrs. Harrington is right. And if you look at the right side there, I have an x-intercept at 4, so I should have x minus 4. Find the equation of a parabola in factored form. Suppose h of x is a parabola that goes through the given points. Find the equation for h of x. So if you notice here, I have a parabola that's concave up. I have an x-intercept at 2 and 6. So because I know one of my x-intercepts at 2, I can put x minus 2 there. My other x-intercept is at 6, so I know one of my factors would be x minus 6. Now if you look at my graph though, it looks like my parabola is a little bit wider than the parabola that they're expecting me to write. So that means that I need to look at that a value, right? It's not going to be 1. So I know because it looks like a vertical stretch, it looks like someone pulled the parabola from the ends vertically, right? And it got thinner, it got narrower. I know that my a value will be greater than 1. I know my a value will be greater than 1. So let me just try 2. Oh, and that works. So it'd be a 2 in the front. So here we have another parabola, and this time I have an x-intercept at only 4, and I only have one x-intercept. Now I know that I'm going to have x minus 4 as one of my factors. And because I only have one x-intercept, I'm going to try x minus 4 again. Now I do have a parabola that crosses the x-axis once, but if you notice here, my parabola is concave up while theirs is concave down. That means I need to change that a in the value in the front to make it negative. But now if you notice, it's still not quite right. It looks like I need to change the wideness of my parabola. Here, the parabola that they want me to come up with is wider than the one that I have. And because it's wider, it's what we call a horizontal stretch. That a value in the front must be less between 0 and 1. So I'm going to try 1/2, which is just 1 divided by 2. And it looks like it works out. Nice. So here we're given h of x is a parabola that goes through the given points with vertex at -3, -4. Find one possible equation for h of x. So here, try typing your answer in that given factored form. So I already know one of my x-intercepts at -5. So one of my factors should be at x plus 5. To figure out my other factor, I need to figure out where does my other x-intercept have to be. Now if my parabola is at x equals -3 and I have an x-intercept 2 units to the left of it, my guess is because parabolas have this line of symmetry in the middle that goes through the vertex, my other x-intercept should probably be 2 units to the right of the vertex, which would be at -1. Now if I have an x-intercept at -1, then I know that my other factor should be x minus -1, or just simply x plus 1, right? And if you notice, that is a correct graph. So once again, it's the same kind of situation here. One vertex, one x-intercept. So now I notice that one of my x-intercepts is at 4. So I know one of my factors has to be x minus 4. And then from there, I need to figure out my other x-intercept. So using that symmetry, I notice that I'm going to probably have to go 3 units to the left of my vertex. Now if my vertex is at x equals 1, or situated at the x value of 1. So if my vertex has an x value of 1, I need to go 3 units to the left of that, and 1 minus 3 is -2. So my graph must cross at x equals -2. Again, x minus -2 is really just x plus 2. And looking at what we have, so it's still not right. And if you notice, it's because this probably needs to be concave down, huh? Because my vertex is at the very top. So what that tells me then is I need to put a negative here. And that works out nicely. So here the graph of f of x is given with an x-intercept at 15, 0, and an axis symmetry at x equals 8. What is the other x-intercept? So if I know my axis symmetry is at x equals 8, and the x-intercept is 5, 7 units to the right of it, I know that my vertex is in between the x-intercepts. So that tells me that this is probably going to be at 1, right? 7 units to the left of 8. Always remember the vertex is right in between the two x-intercept values. Finally, suppose f of x is a parabola with x-intercepts at -8, 0, and 24, 0. What is the x-coordinate of the vertex, and how did you find it? So because we know the vertex lies right in between the two x-intercepts, we want to take the average of the x-intercepts. So if I take -8 and add it to 24, I get 16. And 16 divided by 2 is 8. You're thinking, just what I said before, the vertex is right in the middle of the two x-intercepts. So you're going to take the x-coordinates of your x-intercepts, average them out, and I know my vertex has to lie there. So that's your Desmos activity. So hopefully you get a better idea of how the quadratic function in factored form works, how you can graph something in factored form. At this point, go back to your guided notes because we are going to be looking at a problem together. All right, so let's take a look at this. So here we're given a equation in factored form, which is right here. And what we're going to do is we're going to be graphing it, right? And finding a bunch of other characteristics. So what are the x-intercepts? So one of my factors is x minus 2. So I know my x-intercept will be 2, 0. I have another factor that's x plus 4, which means my other x-intercept should be -4, 0. If you ever forget what my x-intercept is, whether it's 2 or -2, another way you can do this is by setting each factor equal to 0, and then just solving for x. X equals 2 and x equals -4. Look at what happens if you take x equals 2 and plug it back in, right? If you plug 2 in for x, what do you get here? You get 0. You have negative in the front, right? Negative, and then the 0, and then times, to plug in 2 here, I get 6. 0 times anything will always be 0. So if you notice that when I plug in 2 into my function, I get my output to be 0. By the same reasoning, if I look at -4 here, if I plug -4 in, I'll get -6 here, right? -4 minus 2 is -6. And then -4 plus 4 is 0. So again, anything times 0 is 0. And that's the reason why you can just set each of the factors equal to 0 to find your x-intercepts, right? Because remember, zeros and x-intercepts are really the same, more or less the same. What is the y-intercept? So the y-intercept is a point that crosses the y-axis. And so that's when x has to be 0, right? Just look at any point on the y-axis, right? The x-coordinate of that point will be 0. So all I'm going to do is plug 0 into my function. In other words, anytime I see an x, I'm going to replace it with a 0. And then from there, we're going to carefully just simplify this out. And you end up with +8. So my y-intercept is 0, 8. At this point, let me just plot what we have so far. I have 2, 0. I have -4, 0 as my x-intercepts. I have 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now to find the vertex, I know that my vertex lies between these two x-intercepts. And the way you can find the x-coordinate is by simply taking the two x-intercept values and averaging them out, right? Add them up, divide by 2. And if you simplify this carefully, you do get -1. So that tells me that my x-coordinate of the vertex is -1. But you still need to find the y-coordinate, right? Because a vertex is a point, right? And every point has an x and a y. And so we need to plug -1 in. Once again, all we're doing is we're taking -1 and we're plugging it into the function that we defined previously, right here. So every time I see an x, I'm just replacing with -1. And then from here, I'm going to carefully simplify this. -1 minus 2 is -3. -1 plus 4 is +3. And if you multiply this out, you should get 9. Now my vertex is -1, 9. You always want to write your vertex as a point, okay? So from there, let me plot -1, 9, which should be right here. And now the next question is, what is the axis of symmetry? So the axis of symmetry is the line that cuts the parabola in half. And if you remember, it always goes through the vertex. So this was the vertex, right? So I know my axis of symmetry should be cutting down like that. And so in that case, my axis of symmetry is a vertical line, so it's x equals. In this case, it goes through the x-coordinate of the vertex, which is -1. Now they wanted us to draw a graph using a minimum of 5 points, but if you notice, based on everything we found, we already have 4 of the points. To find the 5th point, we'll use symmetry. If you notice here, I have this point right here, 0, 8, my y-intercept. If I go to the left 1 unit of the axis of symmetry, I'll get my other point. Always use the fact that the parabola is symmetric about the axis of symmetry. you can always get free points without having to plug anything in for x, okay? In the end, when you draw your graph, it should look like this, a parabola that's concave down, which is the answer for our next question, right? Number 6, what is a concavity? You can just say down or just concave down to be more exact. If you remember, a frown is concave down, a smile is concave up, right? Lastly, does a function have a maximum or minimum value? So if you look at this parabola, right, notice where the vertex is at. It's at the top, right? That tells me that there will be a maximum value. Right, there's a maximum. And what is that maximum value going to be? Well, it's going to be the y coordinate of the vertex, which is 9. Right? If you were to climb up to this vertex, the highest point you'd reach is a y coordinate of 9. You notice we're not looking at the x coordinates for the minimum or maximum value, but the y coordinates, okay? So hopefully you guys understand how to graph a quadratic function in factored form. Take a close look at what we just did here, right? And understand all the components to it, because there is a lot going on. Understand that when you have something in factored form, you can easily find the zeros or the x-intercepts, right? And you can use that to graph a lot of the other, you can use that to find the vertex, right? And things like that. So when you feel ready, what I want you to do is I want you to go to the next page. I want you to do as much of this as you can on your own. Do it to the best of your abilities without any notes or outside help, right? So I'm gonna give you guys a couple of minutes to do this. Pause the video, and when you're ready, press play to check your answers, okay? So after you have finished that, what I want you to do is look at this rubric here at the end. I'm not sure if you've worked with a rubric before, but we're going to use a rubric today, and I'm going to walk you through it. You might think it's only the teacher's job to use a rubric to look at students' work, but today you will play the job of a teacher, right? It'll be your job to look at your own work and to think about how well you understand this content, okay? You also use this rubric in the self-assessment activity to reflect on your own understanding of the content and the steps you can take to reach those learning goals. So let's take a look at this rubric here. If you notice, there are 4 possible ratings you can receive. That will depend on how well you do this self-assessment activity, right? 1 through 4. You'll be graded on the number of questions that you choose a point value for when you're doing the self-assessment, because essentially you're just grading your answers. Whether you tally your points at the end, as well as whether you include reflection or not. Let me show you the self-assessment form that you're going to be filling out in a bit. I can just kind of walk you through it so you can see how it works. So for the self-assessment activity, you're going to put your initials there. Essentially, all of the questions that you just answered are here along with your solutions. And you're going to just carefully grade your work, right? So what are the x-intercepts, right? If I just got only one of them correct, I'll put a 2 there. For the y-intercept, if I got that right, I'll get 2 points. What is a vertex? If I got that wrong, I'll put 0 points. And you're going to carefully go through all the questions and grade it to the best of your abilities, right? And then at the very end right here, after you grade the first 7 questions, you're going to tally up your points, right? Type in your points there and enter it. And then after you do that, I want you to use those points to look at this chart at the bottom to see how you did, okay? So at the end, there's this chart for you to read your results based on the total points. And then from here, what I want you to do is look back at your own work and reflect on 1 or 2 areas you feel you understand well, 1 or 2 areas you feel need improvement, and then any steps you will take to improve your understanding of this content, okay? So just so we're clear, this rubric will determine your grade for this self-assessment activity, okay? Not how many points you received on the questions you just answered. So it is of utmost importance that you conduct this self-assessment with honesty, as it's really meant to help you determine your level of understanding regarding quadratic functions in factored form. All right, guys, conduct your rubric, conduct your self-assessment activity, and let me know how it goes. Hope you guys have a wonderful rest of your